So we're going to take a look at some models of linear functions in real world situations just to start thinking about the context of the equation of a line. So you have here a construction crew is lengthening a road. The y represents, let y represent the total length of the road in miles, and let x represent the number of days the crew has worked. Suppose that x and y are related by the equation y equals 3x plus 36. Now remember, our x, that's like our input, our independent variable, right? And we're saying that's the number of days. And our y, if we're in function notation, that's like our f of x, and that's our output. And that represents the length of the road. So if we have y equals 3x plus 36, this is slope-intercept form. Our y-intercept is 36, and our slope is 3. So let's think about what these mean in the context of this question. Part A says, what was the road's length when the crew started working? All right, so we're asked the length, and we're asked at a time when the crew started working. So at the point where the crew started working, time was 0. Or in other words, we're saying x equaled 0 days. So then if x is 0 days, the length of the road can be found by doing y equals 3 times 0 plus 36, which equals 36. And the units for that would be miles. Essentially, we have our y-intercept here. This is our y-intercept. And notice how this is like, think of it, another way is like the starting point. For this context. All right, the second part says, what is the change per day in the road's length? So we have change per day. That tells me I'm dealing with a ratio, right? The change and the road's length. So we're changing miles, and I use a triangle as a notation for the word change, over per day, 1 day. That's what it's asking for. So that is referring to the slope. And what is our slope? 3. Or 3 miles over 1 day. All right, so you try it. We have owners of a recreation area are filling a small pond with water. Let Y represent the total amount of water in the pond in liters. Let X represent the total number of minutes that water has been added. Suppose that X and Y are related by the equation 500 plus 26X equals Y. So you're asked, what is the change per minute in the amount of water in the pond? And B, what was the starting amount of water in the pond? Go ahead and pause the video and answer these questions, and then we'll do it together. All right. So again, looking at the question, we have change per minute. That tells me I'm dealing with a ratio. In this case, it's the slope. That's the ratio. It's 26, which refers to 26 liters per 1 minute. Okay, so that's the answer for the first part. Second part, what was the starting amount of water in the pond? So it's saying, at the beginning, when x equals 0, what is your y value? Which is going to be your y-intercept. And in this case, this is 500, and the units will be liters. All right, let's continue on with another contextualized question. So we have an application problem with the linear function, and we're going to be finding a coordinate given 2 points. So suppose that the weight in pounds of an airplane is a linear function of the amount of fuel in its tank. So basically what that's saying is that if we wanted to model this, we could use y equals mx plus b to model this scenario. When carrying 25 gallons of fuel, the airplane weighs 2,240 pounds. Okay, think of that as one ordered pair on our line. When carrying 45 gallons of fuel, it weighs 2,352 pounds. So that would be like a second point on our line. How much does the airplane weigh if it is carrying 60 gallons? So that will be another point, although we only have part of it. So if we look at the sketch of the graph that's given below, we can see that on our x-axis, we are graphing the amount of fuel in gallons. So our x variable relates to the amount of fuel. And on our y-axis, we're graphing airplane weight in pounds. And so if I write that first point as an ordered pair, the x value is going to be the 25, and the y value is going to be the 2,240 pounds. The second point, we're going to have 45, comma, 2,352. And the third point will be 60, comma, and I will just put y since we don't know what the weight is for that point. Okay, the question is asking us to find the y. So I'm going to show you two strategies of solving this question. One is to use the equation of the line to solve for y. So we'll start there. If we want to solve for y using the equation of a line, the first thing we do is find the slope. Now, it's not practical to use graph paper to count the slope, so you should use the slope formula, which would be m equals y2 minus y1 over x2 minus x1. All right, so I'm going to use the 25 and 2240 and the 45 and 2352. So I'm going to do 2352 minus 2240 over, and now our x value is 45 minus 25. Okay, now these questions are on your application assignment where you are permitted to use calculators on these. It says it right on the assignment. Okay, so it is okay to use a calculator to evaluate this. So we have 2352 minus 2240, and that gives us 112 over 45 minus 25, which is 20. Let's see what happens if we divide that fraction. 112 divided by 20, and you get 5.6. Let's write that. We'll work with the 5.6 as our slope. Okay, second part of writing the equation of a line. is to find the y-intercept. So we're going to use one of the points. So I'm going to use the point 25, 2240. But if you wanted to use the point 45, 2352, that would have been fine as well. And we're going to substitute into y equals mx plus b. So the y value is 2240 equals the m value, our slope is 5.6 times our x value is 25 plus b. Okay, let's solve for b. So 5.6 times 25 gives us 140. So we have 2240 equals 140 plus b. Subtract 140 from each side. And that gives us 2100 equals b. Okay. Now, our third step when we're writing the equation is to then write the general equation using slope-intercept form. Y equals 5.6x plus, and then our y-intercept is 2100, right? That's our general equation. Okay, so if we go back to that graph that we were given on the right side, okay, the graph of this line, the equation for it is y equals 5.6x plus, excuse me, plus the 2100. So we think about this point right here, we're saying y is 2100 right there. That's what we're saying. And then it makes sense. We have a positive slope. 5.6 is a positive slope. Okay, so there's the equation of our line. Okay, now lastly, this is a step 4. We got to answer the question. And essentially what we're going to do is use the equation to answer the question. The question was, if x equals 60, then y is what? So we can substitute 60 into our original equation, well, into our general equation to find the value of y. So let's do that. We have y equals 5.6 times 60 plus 2100. Let's evaluate that. 5.6 times 60, that gives us 336 plus 2100. And so y is equal to 2,436 pounds. And that's the answer to our question. All right, so that's how you would use the equation of the line to answer this question. Okay, we're going to start again, and I'm going to just copy our information that we have here. And we're going to use this to solve the question again using a different method. Okay, this time we're going to use the slope formula to write a proportion. So let's remember, a proportion generally looks like this: a ratio like A over B equal to another ratio like C over D, right? This is a proportion. So slope is a ratio. So if I use the slope formula on each side of the equal sign, that's going to give me a proportion. So I'm going to use the slope formula on the left side using the 25 and 2240 point and the 45 and 2352 point. So I'm going to do 23 52 minus 2240 over 45 minus 25. Okay, so that's the ratio on the left side. And I'll simplify that because we did that before. We had 112 over 20. And then that 112 over 20 equal to 5.6. Okay, but what about the ratio on the right side in order to get a proportion? Well, what you need to do here is use two different points on the line. So this time I'm going to use the 25 and 2240 point with the 60 and y. So that allows us to now bring in the part that we're trying to actually solve for. And so this time I'm going to do the y minus 2240 over 60 minus 25. Now remember, this is the slope of the line, so it should still equal to 5.6. Okay, so I'm going to just simplify this further. Y minus 2240 over, and now the 60 minus 25 is 35. And I'll just bring that down to our last line where we ended. Okay. Now, when you have solved proportions, you saw that you can cross multiply to solve the proportion. Well, we only need to cross one side because we got rid of the fraction before we even started on the left side. So we'll multiply the 5.6 to the 35. All right, so 5.6 times 35, and that gives us the 196 equals, and on the left side, you still have the y minus 2240. Okay, let's finish up solving for y, adding 2240 to each side. All right, so on the right side, the minus 2240 and the plus 2240 is 0. And then 196 plus 2240. Oops, try that again. 196 plus 2240. We have 2436 pounds equals y. We go back to the previous answer, 2436 pounds equal y. So you can either use the equation of a line to solve for the unknown, or you can use the slope formula as a proportion to solve for the unknown. Okay, you try it. So we have here the monthly cost in dollars of water use is a linear function of the amount of water used. And we have the cost for using 24 HCFs of water is $37.92. Okay. And the HCFs, as you saw above, is hundreds of cubic feet. And the cost for using 46 HCFs is $67.92. What is the cost for using 28 HCFs? Okay, go ahead and try this. Try it both ways and see which way you prefer. Pause the video, do it on your own, and then we'll do it together. All right, so let's try this. Okay, so again, we have 2 points that we know completely, And so based on the graph, I can see my X, what's on my X-axis is water usage in HCFs. What's on my Y-axis is monthly cost in dollars. So therefore, I'm going to write my ordered pair as 24, comma, 37.92. The second ordered pair, I'm going to write that as 46, comma, 67.62. And then the third ordered pair, I'm going to write as 28, comma, Y. Okay. So we have here 2 points. We'll find the slope. So y2 minus y1 will be 67.62 minus 37.92 over, and then 46 minus 24. Okay, so we have 67.62 minus 37.92 equals 2790 or 29.7 over, and then 46 minus 24, we get 22. Okay, so let's see if that gives us a nice decimal if we divide that by 22. Yes, 1.35, I like it. So our slope is 1.35. Okay, y-intercept. So I'm going to use the point 24, comma 37.92, but you could have used 46, comma 67.62 as well. So we have y is 37.92 equals 1.35. And we're going to multiply that to 24 and then plus b. Okay, so 1.35 times 24, we get 32.4 plus b. So we still have the 37.92. Subtract 32.4. All right, so 37.92 minus 32.4, and we get 5.52 for our y-intercept. So that means our equation of our line is y equals 1.35x plus 5.52. That's the equation of the graph of this line. So now to make the answer to the question, to really, it's like making a prediction. If x is 28, then what is the cost? Okay, so let's do that. Y equals 1.35 times 28 plus 5.52. All right, let's do that. So we have 1.35 times 28, 37.8. And add 5.52 to that, and we get 43.32. And that would be the cost. So we're in dollars. Okay, that's method one. Now let's take a look if we use the slope method. All right, so we have the same information to start. We set this up using the slope. Okay, so the first 2 points I'm going to use on the left side, we have 67.62 minus 37.92 over 47 minus 24. We already know that equals 1.35. So let's do the right side. I'm going to use the first and the second point. So I am going to do y, the first and the third point. Sorry about that. Y minus 37.92 and then 28 minus 24. Now you could use the second and the third point as well. So you don't have to do the first and the third point. You can do, as long as you do the third point in that next combination is what's key. All right, so we'll simplify that y minus 37.92 over 4. Okay, cross multiply this, well, just half cross multiply. So the 1.35 times the 4, we have 5.4 equals y minus 37.92, and then add the 37.92 to each side. So we get y is equal to 43.32 or $43.32, which is the same answer we got using the equation of a line.